You're welcome to the last sequence of questions that we want to look into under the topic sequences and series. So let's dive in. The first one, we're interested in continuing the sequence. If we can check with a common difference, here it's -3, -3. So if we are continuing, it's 4 minus 3 gives us positive 1, and 1 minus 3 gives us -2, minus 3 gives us -5. Then the pattern continues like that. Right, moving on, recognize the sequence. We are testing which type of sequence this is. Well, my position here is position 1, position 2, position 3. And as I am seeing this, looks like I'm raising to the power 4. So the sequence is n to the power 4. Right, moving on, we want to continue this type of sequence. And as I'm checking here, it looks like the difference there is 5, and the difference there, say 9, and the difference that I have there, it looks like it's what, 13. So it looks like we are adding 4 all the while. So here we'll be adding 17. So if I say 20 plus 17, it looks like it gives me 45. And to 45, I'll add 21 because we are adding that difference. So when I add here, I'll get 66 as the next value. And here I'll be adding a difference of 25. 25, it will give me 1 there, 91 like that. So my pattern will continue in that particular behavior. So yeah, that's the continuation that I'll get from that pattern. Right, given this function is subscription notation, let's write the first 5 terms. Right, so the first one is given already, it's a 2. And the next one is going to be U2. So U2 is equal to U1 plus 5 when we substitute here with 1 and 1. Then when I do so, I'm adding to 5, I'm adding 2. So it gives me 7. Then next it will be U3, which will be, so U3 is U2 plus 5. So that will be 7 plus 5. Actually, it will give me 12. So it looks like we are continuously adding a 5. And the next I'm expecting to get 17, and I'm expecting to get 22. The pattern continues like that. Right, moving on, find the nth term. Nth term, we first start by checking for difference between consecutive terms. So here we have a 5, and there 5, 5. So it looks like we having 5 all the while, so we're adding 5 all the time. So that's arithmetic. We have 5n, but the first term, 5 times 1 is a 5, but here we have 6, so we add a 1. That's our formula there. Moving on, find the nth term of that given pattern. If I check there, it looks like here the position is 1, there is 2, there is 3, there is 4. But now when I check, it looks like this is a square of 3, square of 5, square of 7. So in essence, it looks like we are dealing with odd numbers for the position to square. Let's try and have a look. Odd numbers. 2n minus 1. When n is 1, 2 times 1 minus 1, it gives us 1. So what about is 2? 2 times 2, that's 4 minus 1, 3. So it looks like that's our formula there. We can say Tn equal to Tn minus 1, which is the formula to get the position of interest. Then we square it, gives us the result that we have in there. Moving on, find the nth term. Another pattern again, we'll check for the common difference. There is a 5, 7 and 16, 9, 16 and 29. Looks like it's 13. So in essence, we are adding 4 all the while. But we are interested in the nth term. So Tn will be equal to an squared plus bn plus c. So this is quadratic. Then what do we do with this? We know this is equal to 2a. In other words, our a is actually 2. So we can come and say Tn equal to 2n squared. But what about the 5 we have there, which is the first difference? Is 3a plus b equal to 5. But a is 2, so it will be 6 plus b equal to 5. It looks like our b is -1. Therefore, I'll come and say minus n. What about the first value? I have 2 there. A plus b plus c is 2. A has been found is 2, b is -1, plus c equal to 2. Then 2 minus 1, it gives us 1 plus c. So it looks like there is a 1. So let's try and roughly test with the second position. Our n1 is 2, so it's 2 cubed. It will give us 8. So let me try term 2. Say if I get 7. So 2 squared, that's 8 minus 2 plus 1. So 8 minus 2 is 6 plus 1, 7. So it looks like this formula here is correct for that given pattern. Find the 15th term of, so we are given in subscription notation, so we are interested in U15. U15 is going to be 7 multiplied by 15 minus 3. Well, if I multiply 7 by 15, 7 times 5, that's 35 carry 3. So it will be something like that, which will give us 102. That's the 15th term. Show that the sequence 1, 2 is cubic. Well, if I want to show that is cubic, my positions 1, 2, 3, 4. If I cube my positions, well, I get the respective terms. So my formula is going to be Tn equal to n cubed. Then write the first 4 terms of the sequence. So we're interested in the first 4 terms. So U1, there's a 1 there. So it will be, if I say U1, let's say U1, it will be 3 times 2 to the power 0. So the first term is 3. What about on position 2? It will be 3 times 2, that's 6. Then the third term, it will be 3 minus 1, 2 squared, that's 4 times 3, 12. So it looks like we are doubling all the time, starting with a 3. Therefore, I'm interested in the next term, 3, 6, 12. It will be 24. The pattern continues like that. I think basically that was it on the first 10 problems. Let's have a look at a bonus question. The sequence is the nth term, un equal to n squared plus n. We know n is the position. Write the first 4 terms of the pattern. So u1 is going to be 1 squared plus 1. So the first term is 1. What about the second one? 2 squared, that's 4 plus 2, 6. Then we are moving to the next one, 3. 3 squared plus 3. So it will be 9 plus 3, that's 12. So 2 times 3, 6. 6 times 2. Wow, we are interested in the fourth one. Fourth one is going to be 4 squared, that's 16 plus 4. That will be 20. And then the pattern will continue like that. So this was solution to A. B, state whether the sequence is linear or quadratic. Obviously, we can see the highest power is 2 there. Therefore, this pattern is quadratic. Now, we are required to find the 10th term. So if we want 10th term, it's as good as U10. It will be equal to 10 squared plus 10. And 10 squared, we know it gives us 100 plus 10, so it will be 110. I think, folks, that was it for extended mathematics sequence and series. Let's meet in the next discussion. Bye.